How can a sauce made mostly of oil stay thick, smooth, and stable when oil and water usually split apart almost instantly? That is what makes mayonnaise so strange. By US standards, mayonnaise is an emulsified semi-solid food made from vegetable oil, acid like vinegar or lemon juice, and egg yolk ingredients, and it must contain at least 65% vegetable oil by weight. So this creamy spread is not a little bit of oil hiding in something else. It is mostly oil, yet it behaves like one smooth sauce. At first glance, mayonnaise does not seem like a big scientific mystery. It sits in sandwiches, burgers, salads, and dips, and most people barely think about it. But mayonnaise is actually a very elegant answer to a basic problem in chemistry. Oil and water do not want to stay mixed. Shake them together and they separate. But in mayonnaise, millions of tiny oil droplets are held in place inside a water-based phase, creating a stable oil in water emulsion. That is why mayo feels smooth instead of greasy and why it spreads like a cream instead of pouring like straight oil. In this video, we are going to look at what mayonnaise really is, why egg yolk matters so much, why adding oil slowly changes everything, why mayo gets thick instead of thin, how it can break, and why something so common is actually a great example of everyday science. What mayonnaise really is. The simplest way to understand mayonnaise is this. It is not oil disappearing into water, and it is not water disappearing into oil. It is oil broken into tiny droplets and dispersed through a water-based environment. In mayo, that watery part comes from ingredients like egg yolk, vinegar, lemon juice, and any added water in the formulation. The oil is the dispersed phase, and the watery phase is the continuous one holding everything together. That is why mayonnaise is classified as an oil in water emulsion. If you just pour oil and vinegar into a bowl, they separate because they have very different molecular behavior. Water molecules strongly interact with one another, while oil molecules group together and avoid mixing with water. Vigorous mixing can temporarily break one into droplets, but without help, those droplets collide, merge, and separate again. Mayo only works because something steps in to stabilize that mess. Why egg yolk changes everything. That stabilizer is mostly egg yolk. Egg yolk contains emulsifying molecules and proteins that can interact with both oil and water. Exploratorium explains that many yolk proteins have one part that is attracted to water and another that is attracted to oil. Lecithin, another important emulsifier in yolk, has a water-loving head and a water-fearing tail. That lets it sit at the surface of an oil droplet like a protective layer. Once those yolk molecules coat the droplets, they help stop the droplets from touching each other directly and merging back into larger pools of oil. Oklahoma State's Food Emulsifier Guide describes emulsifiers as compounds that reduce interfacial tension and help prevent aggregation, while the American Egg Board notes that egg yolk reduces surface tension and helps create the droplets that make up an emulsion. In simpler words, egg yolk acts like a molecular peacekeeper. It helps two ingredients that do not get along stay in the same room without fighting. Why you add oil slowly. This is the part that matters most in the kitchen. When making mayonnaise, the oil is usually added very slowly at first. Britannica notes that classic mayonnaise is formed by continuously beating egg yolks while oil is added little by little. That is not just tradition. It is chemistry. Each new bit of oil has to be broken into tiny droplets and coated by emulsifiers before more oil arrives. The American Egg Board puts it very clearly: oil needs to be added slowly so lecithin in the yolk can coat the small droplets thoroughly. If too much oil goes in too quickly, you create more new droplet surface than the egg yolk can protect. Then droplets start joining back together, and the emulsion can fail. That is why a rushed mayonnaise often turns thin, greasy, or split. Why mayonnaise gets thick instead of runny? This is the part many people find surprising. You might think that adding more oil would make something looser and more liquid. But in mayonnaise, adding oil actually helps make it thicker. The reason is that the oil is not sitting there as one big pool. It is being turned into huge numbers of tiny droplets packed close together inside the continuous watery phase. The more well-dispersed droplets you create, the more the mixture resists flowing. The American Egg Board explains that droplet size, droplet uniformity, and viscosity are critical to emulsion stability. Their guidance also notes that egg yolks help create a viscous continuous phase, which limits droplet movement and reduces coalescence. A University of Richmond cooking science lecture makes the same idea easy to picture by comparing the droplets to a crowded subway platform. Once enough droplets are packed in, the mixture cannot move freely anymore, so it behaves more like a thick cream than a free-flowing liquid. So mayonnaise is thick not because oil is naturally thick, but because the oil has been chopped into tiny droplets and trapped in a crowded, structured system. Why mayonnaise sometimes breaks. The broken mayonnaise is basically an emulsion that has lost control. Instead of many small droplets staying separate, droplets start merging into larger ones. Once that happens enough times, the mixture cannot hold together and it begins to separate into oily and watery parts. Exploratorium describes the problem directly. Without an emulsifier, oil droplets coalesce. Oklahoma State says emulsifiers help prevent droplet aggregation and maintain a smooth phase. In everyday terms, mayo usually breaks for one of three reasons. First, the oil went in too fast. Second, there was not enough effective mixing to make small stable droplets. Third, the emulsion got pushed beyond what the emulsifiers and viscosity could manage. That is why the same ingredients can give you either a silky mayonnaise or a loose, separated mess depending on technique. The debated history of mayonnaise. The science of mayonnaise is fairly clear. The history is less tidy. Britannica describes mayonnaise as a cold sauce from French cuisine, but it also says the word's origin is uncertain. One theory links it to Mayen in Minorca after a French victory there in 1756. Other explanations connect the name to Old French words related to egg yolk or stirring. That uncertainty actually makes sense. Food history is often messy, and famous dishes tend to collect legends around them. So the safest way to say it is this: mayonnaise became established in French culinary tradition, but the exact origin of its name is still debated. That is more honest than pretending the story is completely settled. Why store-bought mayonnaise is so consistent. Homemade mayonnaise can be wonderful, but commercial mayonnaise is built for consistency. U.S. regulations define mayonnaise as an emulsified semi-solid food made from vegetable oil, acidifying ingredients, and egg yolk ingredients, with certain optional ingredients also allowed. Those optional ingredients can include salt, sweeteners, spices, some acids, and certain additives that help preserve flavor or improve consistency. The point is not to make it fake. The point is to make the emulsion stable, repeatable, and suitable for storage and mass production. Commercial producers also control mixing conditions, droplet size, temperature, and formulation far more precisely than most home kitchens can. And since droplet size and uniformity strongly affect stability and texture, that precision matters. That is one reason store-bought mayo often feels almost unnaturally smooth. It is the result of controlled emulsion engineering. Myth versus reality. A common myth is that mayonnaise is some mysterious food that should not be possible. The reality is that it follows the same emulsion principles used in many other foods. Another myth is that mayo stays together because oil and vinegar somehow eventually learn to mix. They do not. The real reason is that egg yolk provides emulsifiers that coat droplets and help stop them from merging. Another common misunderstanding is that mayonnaise is thick because it contains less oil. In fact, real mayonnaise contains a lot of oil. The thickness comes from structure, not from low-fat content. The droplets are tiny, numerous, and packed into a stable continuous phase, which gives the sauce its body. Why this matters in everyday life. Mayonnaise is a great example of why food science matters. It shows that texture, stability, and mouthfeel are not random. They come from structure. The same basic ideas behind mayonnaise help explain salad dressings, ice cream, sauces, creams, and many processed foods. Once you understand mayo, you start noticing emulsions everywhere. It also shows something bigger. A lot of ordinary foods are full of hidden design. They look simple because we are used to them, not because they are simple. Mayo is just a spread in a jar, but inside that jar is a tiny engineered system made from droplets, interfaces, and molecules doing very specific jobs. So why doesn't mayonnaise separate? Because it is not just oil and water mixed together. It is oil broken into tiny droplets, suspended in a water-based phase, and protected by emulsifiers from egg yolk. Add the oil slowly, create small droplets, coat them well, and you get a thick, smooth emulsion. Lose control of that system, and it breaks. That is the whole trick. And that is what makes mayonnaise such a great everyday mystery. It looks simple, but it is really a lesson in chemistry hiding in your sandwich. If you enjoyed this video, let me know what ordinary food or household item you want explained next. If you enjoyed this video, please like, share and subscribe. Then tap the bell icon to turn on all notifications so you never miss any of our future videos.